Back, problem 5. Suppose that fx is this function. Find derivative and find domain. All right. They are saying use I for infinity, negative I for, let's see. Okay, first, domain. I hope I haven't made any mistake in copying x squared, natural log 13 minus 2x squared. Okay, no problem. Domain. So notice the argument for natural log must be positive. 13 minus 2x squared must be positive. You see, this is a parabola. And because of the negative leading coefficient, your parabola opens down. And it has x-intercepts. Well, how do you find x-intercepts? Set this equal to 0, solve for x. X has to be plus minus square root 13 by 2. So it's an upside down parabola which crosses the x-axis on these two numbers. So when is it above the x-axis? Between these two numbers. So that's where your argument for natural log is positive. So that is domain. You see, the other part, x squared, is well and fine. It's simply multiplying, and x squared is polynomial, monomial, whatever. So it has it's valid for all real numbers. It's only the natural log which curtails some of the numbers, right? So your domain is determined by the positivity of the argument for natural log. So that's your domain. Now find the derivative. Well, you need to use product rule and then chain rule for the second part. Product rule, derivative of the first, second as it is, plus first as it is, derivative of the second. You see, I had to use chain rule here. So that is 2x natural log 13 minus 2x squared minus 4x cubed over 13 minus 2x squared. So that gets me derivative 2x natural log 13 minus 2x squared minus 2x squared close parenthesis minus 4x power 3 over 13 minus 2x squared. That's your derivative. What about the domain? The domain is negative square root 13 over 2, comma, positive square root okay, 13 over 2. All right, let's check. Good, fantastic. Sixth question. Let fx be this rational function. Quite a few complications. Use logarithmic differentiation, so that will make things easier. So let's go. I hope I have copied the question correctly. X squared, x minus 3 power 8, x squared plus 7 power 6. Okay, so that's my function fx. To find the derivative of this, first set y equals your given expression. Then take natural logarithmic function of both sides. Natural log y is natural log of this. Natural log of numerator and denominator, of a quotient, natural log of the numerator minus natural log of the denominator. Numerator itself is a product. So natural log further splits it. So essentially you have natural log of y is natural log of x squared plus natural log of x minus 3 power 8 minus natural log of x squared plus 7 power 6. At this point, natural log of y, use the power property. The 2 comes out here, 8 comes out here, and 6 comes out here. All right. Now when you take derivative, you use chain rule 1 over y prime and derivative of the right hand side. 2 is a constant. Derivative of natural log x is 1 by x. 8 is a constant. Derivative of this is 1 over x minus 3. Chain rule fetches me just 1. Minus 6 is a constant. Derivative of natural log x squared plus 1. 1 over x squared plus 1 times chain rule 2x. So essentially I get 2 by x, 8 by x minus 3 plus minus 12x by x squared plus 7. So how do I find y prime? Take the y to the other side. Y prime is y times your expression. So derivative is y prime. Y prime is x squared, x minus 3 power 8 divided by x squared plus 7 power 6 and the entire expression here. So let's see. Hopefully WebWork will not complain. So first x squared, x minus 3 power 8 over x squared plus 7 the whole power 6. So that was the factor outside. And now we start with the other factor, 2 by x plus 8 by x minus 3 minus 12x by x squared plus 7 and close the opening parentheses here. Let's check. Fantastic. Next, fx equals 4 sine x plus 4x to the x. Find derivative. Aha, that x to the x is an interesting one. So consider that separately, call it gx. X to the x. Take natural log of gx. That's natural log of x raised to x. The x jumps out. X times natural log of x. This is natural log of gx. Now you're ready to take derivative of both sides. Left hand side, derivative with respect to x natural log of gx equals derivative with respect to x of x natural log x. Its derivative is 1 over gx times g prime x equals, derivative here splits by product rule. 1 times natural log x plus x times derivative of natural log x is 1 by x. They cancel. You have 1 there, natural logs here, and to find the derivative, multiply by gx. Gx times natural log x plus 1. What was gx? Gx was x to the x. Okay, so it is not x natural log x, it is x raised to x. So derivative of fx is 4 cosine x plus derivative of g. Okay, so I need to fix that. Gx is, I need x to the x here. All right, so let's see. So derivative of the first piece, 4 cosine of x plus 4 derivative of x raised to x. All right, I need gx, which is x raised to x, and then times natural log x plus 1. All right, fantastic. The last question, 4 raised to x log base 9 of x. Find its derivative. Well, 4 raised to x, you know its derivative is 4 raised to x natural log 4. Log base 9, you know its derivative. It is like that of natural log, but except you have to divide by natural log of 9. That's it. When you use product, you need to use product rule. So derivative of the product is derivative of the first, second as it is plus first as it is derivative of the second. That's it. 4 raised to x natural log 4 log base 9 of x plus 4 raised to x over x natural log 9. Let's check. Log is missing inputs. Oh, I see. It probably doesn't know this. So now what is natural log? Log base 9 is nothing but natural log over natural log of 9. Now let's try. Okay, so that completes our problems from section 6.4. We'll continue with new topics in our next videos. Until then, bye.